Namaskar. In this video, I will discuss the limiting reagent. It is very useful and very much important as far as the numericals are concerned. So let us study the limiting reagent. Limiting reagent may be defined as the reactant which gets completely consumed during the completion of the reaction. For example, if you go to a function and you see that all the eatables are full in stock, ice cream, fruit chaat, cold drinks, etc., they are full in stock, and when that function is about to over, you are coming back and you see that the ice cream is not full in stock now. It is that item which is completely consumed. So ice cream will be the limiting reagent. Means the reagent which get completely consumed during the completion of the reaction is called the limiting reagent. So let us find out the limiting reagent with the help of a numerical. The numerical is how much ammonia is produced when 7 gram nitrogen and 2 gram hydrogen are allowed to react. When 7 gram of nitrogen and 2 gram of hydrogen are allowed to react, then how much ammonia will be produced? So it is clear that nitrogen and hydrogen, they are the reactants. So out of these two, there will be the limiting reagent, and that limiting reagent will decide how much ammonia will be formed. So the product formation is always dependent on the limiting reagent. So we have to find out the limiting reagent first. Let us write the balanced chemical equation. Balanced chemical equation for the particular reaction is N2 plus 3H2 2NH3. That is 1 mole of nitrogen, 3 moles of hydrogen. When combined, then 2 moles of ammonia are formed. So first of all, we have to write the balanced chemical reaction. So this is the balanced chemical reaction, and we see it is 1 mole and it is 3 moles. So by using the mole concept, mole in terms of mass, 1 mole of nitrogen means 28 grams and 3 moles of hydrogen will be 6 grams, because the molecular mass of H2 is 2 gram and multiplied by 3 it will be 6 gram. So 6 gram hydrogen requires 28 gram nitrogen. So let us see how much nitrogen is required by 2 gram hydrogen, because in the numerical 2 gram hydrogen is given. So we have to go according to that condition, or you can say that mass of hydrogen also. So it is clear that 6 gram hydrogen requires 28 gram nitrogen, or when 1 gram hydrogen requires 28, obviously divided by 6 gram nitrogen. So 2 gram hydrogen will require 2 into 28 divided by 6 grams, means 3 and 3 9s are 27, decimal 1 0 10 and 9.3 gram nitrogen. So it is clear that for 2 gram of hydrogen we require 9.3 gram of nitrogen according to the balanced chemical reaction. But in the numerical, hydrogen is 2 gram and nitrogen is 7 gram. But how much is required? 9.3, but it is 7. So nitrogen is the limiting reagent. So nitrogen is the limiting reagent because it will get completely consumed during the completion of the reaction because it is present in the lesser amount. Again, I can repeat that according to the calculation, for 2 gram of hydrogen, 9.3 gram of nitrogen is required. 9.3 gram of nitrogen is required. But in the numerical, 7 gram is given. It is lesser, so it is the limiting reagent. So it is the limiting reagent. Now, the formation of product or the formation of ammonia will not depend on hydrogen. It will entirely depend on the nitrogen because nitrogen is the limiting reagent. So our calculation will be between nitrogen and ammonia only. So again, by using this balanced chemical reaction, we will see this is 1 mole and this is 2 moles. Taking their gram molecular masses, it is 28 gram and it is 2 into molecular atomic mass of nitrogen is 14 and that of 3 hydrogens it is 3, 14 and 3 70 and it is equal to 34 gram. The molecular mass of ammonia is 34 gram. So 28 gram nitrogen will produce 34 gram ammonia. It is according to the balanced chemical reaction. And 1 gram of nitrogen will produce 34 divided by 28 gram ammonia. But according to our numerical, 7 gram nitrogen is given and 7 gram nitrogen is the limiting reagent. So we have to calculate the product formation according to the limiting reagent or according to the mass of the limiting reagent, and that is 7 gram. So 7 gram nitrogen will require 7 into 34 divided by 28 gram and it is 4 and 4 8s are 32, remaining is 2 decimal and 24 5s are 28.5 gram ammonia. So this is the answer. When 7 gram of nitrogen and 2 gram of hydrogens are allowed to react, then 8.5 gram ammonia will be produced. And this calculation is entirely based on the limiting reagent. First of all, about 9.3 of nitrogen was needed, but according to the given set of conditions, 7 gram nitrogen was given. So 7 gram nitrogen was the limiting reagent, and we have calculated the product formation according to 7 gram of nitrogen because it was the limiting reagent. And I hope now it will be clear to you. And this was the concept of limiting reagent. Thank you very much.